Welcome. In this demonstration, we're going to work with Poisson distributions. So what I have in front of you is a spreadsheet where I have ice cream store visits. So we're going to look at the count of visits for the average customer in a given month, a given week, that type of thing. So this qualifies as a Poisson process, which is essentially counting of an occurrence over a period of time. And that's important. So we have to know that it qualifies as a Poisson process before we can use a Poisson distribution. So we have the type of weather here. It might be hot, it might be mild, or it might be cold. And we know for any given month that the average visits per customer, let's say, are 6 in a hot month and 2 in a cold month, and mild month, and 1 in a cold month. And again, I want to demonstrate some good practices with building mathematical models in Excel. So I'm going to highlight these in a color that indicates to me months from now when I come back to use this, oh, these are the ones that I'm changing. I'm changing those. All right. So we have average per month, but I'm interested in some answers about this week, right? So the first thing we would want to know is, well, what's the weather in this week? So let's get that question posted here. So what is the weather this week? And we can use a drop-down list to pull from the weather categories that we have. So I'm going to select data. I'm going to select the drop-down list and the data tool for data validation. I'm going to select list, and my source will be hot, cold, or mild. So now I can choose hot, cold, or mild for the weather. And this is something that I'll be changing, so we'll put it in yellow. Now, I also have to know, based on the weather then, what are the average visits per week per customer? That's what I'm really interested in, and that's what the hot weather gives me. So let's call this variable D. And we're going to calculate that using a switch statement that relies on our drop-down list in E5. So we're going to say equals switch, and my expression is E5. And if it's A5, if the expression equals A5, then I want A6. And if it's, B5, here we go. And if it's A6, I want B6. And if it's A7, I want B7, and I'll throw in a default value of 0. Now, that's not quite right. I haven't finished the formula because I'm asking about per week, and this is an average visit per month. And so what I want to do is multiply that, so we're talking about a month, so multiply it by 12 and then divide it by the number of weeks, so 12 months and 52 weeks. And then I can come up with, well, there's that many visits. I don't need that many visits per week. I don't need all those decimals, so let's just round it here visually to 1.4 visits per week if it's a hot week, okay? So now we have to know, well, what question are we asking? So the type of question we might ask is, what is the probability that customer visits a certain number of days in a week? So this is variable E. So let's give it a place where we can insert that. So we're just going to put this in, right? So we're going to ask in a given week, what are the odds that a customer will visit once during that week? So it's a period of 7 days. Could be a different period, but based on our assumptions here, the ice cream store is open 7 days a week. We would change this calculation up here to adjust for how many days it's open. So, and much like the binomial distribution in a previous video demonstration, we need to understand this probability as either no more than or exactly. And so I'm going to use the same kind of expression that I used in that one. And that is that if it's exactly, meaning that if exactly one visit this week then that's going to be represented by a 0. But if it's no more than one visit, that will be represented by a 1. And so I can make my drop-down list, going up to data. And I can then use a switch statement to evaluate that. Okay, so in the future I will adjust that, so we'll put it in yellow. So what's my answer? Well, now I need to use the Poisson function. Let's put that in green to denote that as the answer. So equals Poisson distribution. And the Poisson distribution asks me for the value, the criteria that I'm using here, the X. And in this case, I'm asking, well, how many days? So how many days will they visit is in E9. And then my mean, that's that average, okay, that I've calculated. So the average visits per month, I have those, but I've calculated it per week. And so that is going to be found in E7. And then is it cumulative or not? And so this is determined by F11. So am I saying exactly or no more than? And I can change this to a percentage. So if it's hot weather, what's the probability that a customer will visit 1 day in a week? 35% chance. Well, what about twice in a week? 24% chance. What about 3 times in a week? 11% chance. Well, let's go back to twice in a week. What if it's hot, twice in a week, but no more than twice in a week? So this is currently asking exactly. What about no more than a week? Oh, I'm sorry, no more than twice in a week, 84% chance. What about no more than 1 time in a week? 60% chance. Okay, what if it is, let's say it's mild weather? We have a 90% chance that a customer is going to visit no more than 1 time each week. What about exactly 1 time in a given week? So any given period of 7 days, it would be exactly 29%. What if it's cold? My percentage goes down, 18%. Let's see, what about if I say it's cold and they're going to visit twice in 1 week? There's only a 2% chance. Notice over here that our average in cold weather is 1 per month. So we have a very low probability that they'll visit twice in 1 week, 1 7-day period. Now we can take these calculations and this experimentation and build a table that gives us an idea. And I'm going to copy this over rather than building it for you. These are just hard-coded values that I'm looking at either exactly or no more than. Let's expand that a little bit so you can see that. If it's hot weather, mild weather, cold weather, and how many days they'll visit in any 7-day period. So 1 day, 2 day, 3 day. And let's verify this. So if it is hot weather, what are the odds, probability that they'll visit exactly 3 days? And here we have our 11%. Now, I've just copied this over by right-clicking on the cell and selecting this values one, and it pastes the value in there. And also notice that I've changed this to a percentage. So let's do the same with this one up here. And it's only displaying for me the whole number percentage, but it's actually storing everything that was calculated. All right, so there you have it. That is the implementation of the Poisson distribution in Excel using the ice cream store visits as an example.